In this presentation, we will observe the chemical reaction of potassium hydroxide and copper 2 sulfate. We will also be discussing stoichiometry and more specifically limiting reactants. Limiting reactants are the reactants that are used at first within a chemical equation. For example, if we had 6 pieces of bread and 2 pieces of cheese, and 2 pieces of bread plus 1 piece of cheese equals 1 sandwich, we would have enough to make 2 sandwiches with 2 pieces of bread left over. The limiting reactant would be the cheese because it limited more sandwiches being created.
This lab asked us to observe the reactions between copper 2 sulfate and potassium hydroxide. But first we needed to set up the lab. The first thing we did was clean out everything to ensure the high success rate of this chemical reaction. We cleaned the burettes, test tubes, funnels, and waste beakers, all with distilled water. Next, it called for us to fill up 2 burettes with 0.2 moles potassium hydroxide and 0.1 mole copper 2 sulfate. In order to do this, we used a clamp to stabilize the burette and a funnel in order to make sure an easy pour inside of it. We then labeled the test tubes to organize the lab even more so. Then once the burette was filled, we filled up 8 test tubes with 5 milliliters of copper 2 sulfate. After this, we added 1 milliliter of potassium hydroxide to the test tube 1, 2 milliliters of potassium hydroxide to test tube 2, and so on and so forth. Then to finish off the setup of the lab, we added the desired amount of distilled water to each test tube for the test tube to equal 13 milliliters, and then stirred it with a clean mixing rod.
The reaction that occurred can be set up in this chemical equation. 2 moles of potassium hydroxide reacts with 1 mole of copper 2 sulfate to produce 1 mole potassium sulfate and 1 mole of copper 2 hydroxide. This is a double displacement reaction because the cations and anions switch between the two reactants to form new products. Before the chemical reaction took place, the potassium hydroxide was a clear liquid and the copper 2 sulfate was a blue liquid. But after the reaction took place, a light blue precipitate started to form at the bottom of the tubes and the supernatant started to form on the top. A precipitate is a creation of a solid from a solution, and a supernatant is a liquid above the precipitate. The difference in these two could be clearly seen as more and more time was given to let the chemical reaction take place. Lastly, after we let the test tube sit overnight, we also observed that the precipitate turned to a black color.
In test tubes 1 through 4, we saw an increase in the production of copper 2 hydroxide. In test tubes 5 through 8, the precipitate yield began to level off. It can be determined that in test tubes 1 through 4, potassium hydroxide was the limited reactant because it controlled how much the product was yielded. In test tubes 5 through 8, the limited reactant switched to copper 2 sulfate as the height of the precipitate levels off. If potassium hydroxide was the limited reactant in test tubes 5 through 8, we would see a steady increase in the height of the precipitate like in test tubes 1 through 4.
Possible reasons for error in this lab would be that we didn't clean out our equipment enough or put film over the test tubes. This would mean that there would still be residue from other experiments and particles from the air which could hinder our experiment.